Hello, this is Jeffrey Cruz for Splat Space again with the next one in our series of videos on simple builds and mods that you can do with the Picoboard and joysticks for using them with Scratch. So this next one was supposed to be about using these two potentiometer joysticks for proportional control and how you'd interface that with the Picoboard and with the program. But the first one about the mini arcade joystick has been getting enough views that I've been getting some feedback, and I did not make enough. I did not make some things completely explicit the first time. I just took them for granted, and forgetting that a lot of the people that are going to be using this are people who are really not familiar with hardware or electronics at all, and so I just need to back up a little bit further and make some things more clear, which will also help you make them more clear to the kids you're working with. So I said in the first video that the mini arcade joystick has this connector that has these 5 wires, 4 colored ones and 1 black one, and that the black one is a common ground, and that I had gone and bought 4 of these 3/32 inch mono phone plugs for plugging into the Picoboard, and that all you needed to do was each of the colored ones just needed to run to 1 plug, and that it would solder to the terminal that goes to the tip of the phone plug. Not the base of the phone plug, which is this bigger terminal that runs all the way up the back. That's the ground, and you don't want that one. You want your colored wire that corresponds to one of these switches to connect to the smaller connector right here that runs to the tip. And then one of them, and it doesn't matter which one, actually gets both a colored wire, in this case the orange one, that runs to the tip, and then the black wire, which is the common ground, will solder onto the big base connector, and that's the ground. And of course the black wire is the common ground for all 4 of these directional switches. So you only need to connect it to 1 plug, because on the Picoboard, if you look at it, you got these 4 connectors, and they each have this big brass band at the base. That actually corresponds to the connector that grips the base of the phone plug. And they are all electrically connected. They are a common ground. These 4 smaller brass connectors correspond to the part that are gripping the tip, and they are all separate. So that's why you only need 1 common ground. All of these are actually electrically the same. So that's fine if you're buying your own phone plugs. But I also said in that video that you could use the pre-existing plugs, 3/32 phone plugs, that come with the Picoboard. There are 4 of them, and each of them terminates in 2 alligator clips. Well, the problem is, at least in the one that I got, they're both black. And so you cannot tell which of these corresponds to the base of the plug, which is going to be the common ground, and which of them corresponds to the tip. So if you have a multimeter, that's not a problem. You can just use it, and do the continuity tester on it and find out which of these plugs is the base and which of these plugs is the tip. The base is your common ground. But if you don't have a multimeter, because like me, you're on vacation and it's not around, you can use the Picoboard itself as a continuity tester. Just by plugging it in. We're just going to plug it into terminal A here. And then in Scratch, right, so if you go to Sensing, and we go down here to the bottom where it says sensor button pressed, we're going to click sensor A connected. Notice that I've check marked it. So over here it shows up as false. I could go to normal readout and say sensor A connected false. I'm just going to go to large readout to make it easier. So it says false because these 2 wires are not connected. But if I connect them, of course, it says true. And I disconnect them, false, connected, true. So now what I can do is I can say, well, which of these is the ground? Well, let me touch one of them to this big ground connector at the base here, and it still says false, so that must just be the ground because it's not changing anything. If I touch the other one here, it says true. So this is actually the one that corresponds to the tip, because now I'm connecting the tip and the ground and it says true. Actually, if I touch it to any of these, it will say true. So this is the one that corresponds to the tip. So what I can do is just take a piece of tape, and my tape appears to have gone over here. Just take a piece of tape or a Sharpie, magic mark, whatever it will last, and just wrap it around this, because this is the tip. This is the common ground, and this is the tip. And test it again. True, false, true, false, true. Good. And I would just do that with each of my cords, which I already have. And now I know which of these connectors on each of these alligator clips is the ground, and which of them corresponds to the tip, which is going to be your individual signal, A, B, C, D. So then that will allow you to temporarily connect it to these 5 wires, because you only need one of them to go to one of those grounds, and then each of the other 4 is just which of the ones that you've marked is going to get one of these wires, and then you can code it. The other question that people had was, well, how do you do speed control? So ordinarily, I'm just showing the one for Y here, for the Y positive direction. It says forever, if sensor A is connected, change Y by 10. That's completely arbitrary, of course. We can put any constant in here. 1 would be a lot slower, 100 would be too fast. And then when we click this, just to light it up, there we go. When we, whoops, well, I actually have to plug my joystick in. Hang on. Got to put in my D because that's got the ground on it, and then put in my A connector, which is right here. Then, of course, when I'm running this, Scratchy should, if I can, if I've got them hooked up right, where is A, B, C, D? Oh, I'm doing it backwards. This is up. You should be. Activate that, and there it goes. And of course, I've only got the A connected, so I have to manually drag him back down. So that's with 10. Well, if you use a variable, we go to variables up here, and we say create a variable, and we make a variable called speed. Then, in this loop down here, it can say forever if sensor A is connected, change Y by speed. And that number can be controlled by anything. So it could be controlled, for instance, by another loop saying how long have you had it in that connected? How long has sensor A connected been true? And then it could just keep increasing the speed as long as you hold it down, and then set it back to 1 or 5 or whatever your base is when you let go of it. So that would be one way. Another way is, since you're using the Picoboard, you could make it some function of where the slider is, or you could even make it light sensitive or sound sensitive, or you could make it by input by keys. Any of those methods that you use in Scratch to control the variable speed will give you variable speed when you connect your joystick. So I hope that answers the 2 main questions that people were having, and hopefully next time we will be getting on to using these potentiometer joysticks, which are really a lot more fun. So that's all, and thanks.